Okay, everybody. Today we are going to learn about chapter 9.2, which has to do with angle and radian measures. So you guys started your journey on trig last class. Now we're going to talk about how we visualize angles on a set of XY axes. And what we're going to do is we're going to think outside here. We're going to think of a circle. We're going to draw a circle. And we're going to start with an angle. We're going to start with the vertex of our angle at the origin and the initial side of the angle on the positive x-axis. So here's how I'm going to draw this. So here we're going to call this the initial side. Right? And what we're going to do is we're going to travel from our starting point, our initial side, around the circle, right, until we're ready to stop. And that's going to be what's called the terminal side. Terminal means end. Right? So I start at the beginning, the initial side, and I go to the terminal side. I just chose that location. And then what we've done is we've created an angle. And the angle symbol, we're going to use the Greek letter theta most of the time. Sometimes you see X or other symbols. But I'm going to call it theta. So here we've created an angle. It starts at the initial side, ends at the terminal side. Now I want you guys to think about this circle around the outside, right? How can we figure out what our degree measure is of theta? Well, think about a circle. A circle has 360 degrees. So this, even though my drawing's terrible, I apologize, each point here accounts for 1/4 of the circle. So let's call this 0 degrees, where we start. When we've gotten up to the top here, we've gone 90 degrees, because there's 360 in a circle, right? When we've gone down here, we've had 180, we've gone 180 degrees, half a circle. Down here, we've gone 270 degrees. And then back to the start, we've gone 360 degrees. So we can think of this initial beginning point either as 0 degrees or 360 degrees. So another thing, too, is notice how I moved. I started at my initial side and I moved up, right? So if I go this way, that's called a positive. I'm drawing a positive angle. And if I start at my initial side and go down, I'm drawing a negative angle, right? So depending on the direction I go, sorry, I'll get my big head out of the way. Right, so that's basically the anatomy of drawing an angle, and we call this standard position. So let's do some practice. So when you're first starting out this journey, it can be helpful to just label. I call this the 4 corners, even though circles don't have corners. It can be helpful to label here. Okay, so I want to go 240 degrees. So what I'm going to do is I'm going to draw my terminal side, and this is a sketch, right? I obviously, this circle is not very beautiful, so I obviously am not going to take out a measure or anything, but I'm just going to estimate where would 240 degrees be. Well, it's a positive 240, so I'm going to go up 90, then I'm going to go over another 90 to get to 180, and then to get to 240, I would have to go 60. So I'm going to say it's about there, right? That's about 240 degrees. So what I've just done is I've drawn a 240 degree angle. Okay. How about 500 degrees, right? This is kind of a slight, like a strange concept, because we just talked about how a circle only has 360 degrees. Here I want you guys to visualize a yo-yo, right? Imagine a yo-yo. I can spin it around however many times I want. So I can have, I don't know, 4 million degrees if I want. It just means I have have to go around the circle more than once. So what I like to do is, okay, here's what I'm going to do. I'm going to start, I'm going to go around the circle, and I'm back to the initial side, right? That's at 360 degrees. So how much more do I have to go to get to 500? Well, I need to go, oops, I didn't do what I said advised you to do, which is to label this, sorry. I need to go another 140, right? So that I'll land at my terminal side. So this represents 360, and then another 140 right there. Right, so that's now the terminal side. So notice this is 40 degrees. And we can say that this is 500 degrees because I've gone around once and then another 140. Okay guys, so both of these were positive angles. What if I have a negative angle? Right, this time I'm going to start at my initial side as always. But instead of going positive up, I'm going to go negative, right? So I'm starting at my initial side, and this time I'm going to go down 50 degrees. So maybe about there. Right, so that's going to be negative 50 degrees. Okay, so now we know how to draw we now know how to draw angles in standard position. There's some other cool stuff to know about angles. So remember the concept of the yo-yo, right guys? I can spin the yo-yo around however many times I want. Where it stops, nobody knows, right? If it lands at a particular spot, right, boom. If I spin that yo-yo one more time around and land at the exact same spot, that's going to have the same terminal side, right? It's going to have an angle that ends at the exact same point. However, it's going to be 360 degrees more in measure than the other angle. So two angles are coterminal if they have the same terminal side. So I can think of coterminal angles as positive angles or negative angles. So that all probably sounds like mumbo jumbo. Let's actually do a problem. So we're going to practice our drawing, we're going to sketch the angle just like we did up in example 1, and then we're going to find one positive and one negative coterminal angle. So I'm going to go, this is negative 45 degrees. So that means I'm going to go down this way, right? And that'll be negative 45 degrees. Okay, so how will I find a positive coterminal angle? Well, we talked about how if I were to go around the circle another 360 degrees, do you guys see how I'd end up at the exact same spot? And then what if I went around another 360 degrees again? I would end up at the exact same spot. I could keep doing that. I have infinite number of coterminal angles, but I only want to find one positive one and one negative one. So we can do this easily mathematically by either adding 360 to our angle measure or subtracting 360 from our angle measure until we get our positive coterminal angle and our negative coterminal angle. So let's start with our angle, which is negative 45, right? And what if I were to spin around the circle one time? That would be another additional 360 degrees. So if I do negative 45 plus 360, I get a positive coterminal angle, which is 315. Right, so that 315 and negative 45 are coterminal. Okay, what if I want a negative coterminal angle? Well, let's subtract 360, and I get a negative coterminal angle. Now in this situation, we only had to add and subtract 360. Sometimes you're going to see in the next case, we're going to need more than that. Okay, again, we get to practice our yo-yo here, right guys? 395 degrees. So let's start at our initial side. We're going to go around the circle once, that's 360, and then an extra 35 degrees, right? So this is 35, right? And then this is 395. The whole spinning thing is 395. Okay, guys, we want a positive coterminal angle. So we're going to start with the angle they give us, 395, and we're going to add 360. And that's going to give us a positive coterminal angle. Now here's the thing here, guys. To get a negative coterminal angle, what happens if I subtract 360? Am I in negative land yet? Not yet, right? So what I need to do again, I need to subtract 360 again, right? And then I'm in negative coterminal land. Right? Sometimes it takes more than one minus 360 or plus 360. Okay, guys, so now we know about how to draw an angle in standard position, and now we know about coterminal angles. Another super cool thing is we can actually measure these angles in two different ways. So I want you to think back to what you already know about a circle, right? Think about the two ways we can think of measurements in a circle. So I want you to consider a circle with a radius of 1 unit. Radius equals 1. Okay, guys, how many degrees are in that circle? Well, we know every circle has 360 degrees. Right? So we can think of a circle in terms of its degrees, which we're used to doing. But we can also think of a circle in terms of its circumference, which is the distance around the outside of a circle. So think back to geometry, and if we want to know what the circle's circumference is in terms of its radius, it would be circumference equals 2 pi r, right? Or pi d. But since we're given the radius of 1, we can say 2 pi times 1, which is 2 pi. So I can think of my circle as either 360 degrees or as 2 pi units around the circle. Okay, so degree measures are called degrees, and the pi measures, the circumference measures, are called radians. So because I can think of a circle in both ways, I can actually convert back and forth between the degree measures and the radian measures. So, and of course there's a super duper formula for that. To take degree measures and convert to radians, I would take the degree measure times pi over 180. And then to convert back from radians to degrees, I would do radian measure times 180 over pi. So let's do some practice. Okay, so it says convert the degrees to radians and the radians to degrees. So this looks like degrees to me. So I'm going to take 120 times pi over 180. Okay, that gives me 120 pi over 180, but I want to reduce this. And I can see that 60 goes into both 120 and 180. So I can say that's 2 pi over 3 radians. So I didn't write this on the notes, but I'm just going to practice drawing. I'm going to measure, I'm going to sketch this just because extra practice doesn't hurt, right guys? So here we go. So let's draw, we're going to start at the beginning here, initial side, and we're going to go over to 120 degrees, we'll say about there. So this can be thought of as 120 degrees or 2 pi over 3 radians. Okay, I can use the same process with negative angles. So let's do degrees to radians, negative 80 times pi over 180. Right, that gives me negative 80 pi over 180, which I can reduce to negative 4 pi over 9. So again, just for practice, I'm going to sketch that. Okay, so this time I've got myself a negative angle, right guys? So that means I'm going to go down this way. Down to 180, or sorry, down to negative 80, right there. So we're going to call this negative 80 degrees or negative 4 pi over 9 radians. Okay, now let's go the other way. Now let's go from radians to degrees. So here I've got 5 pi over 4 radians. And notice, this time I'm going to flip over the fraction. I'm going to multiply by 180 over pi. And do you guys see what happens with the pi's? They can reduce out. So I have 5 times 180 over 4, which is equal to 225 degrees. So again, let's sketch it. Okay, so 225 degrees or 5 pi over 4. I'm going to start here. I'm going to head down. I'm going to go, so I'm at 180. Now I'm going to go another 45. And now I will have 5 pi over 4 radians or 225 degrees. Okay, grand finale, guys. Let's change negative pi over 12 into degrees. So I have negative pi over 12 times 180 over pi. Right? Pi's cancel out. So I have negative 180 over 12, which is negative 15 degrees. Okay? Sketch it for good measure here. 0, 90, 180, 270. Okay, negative 15 degrees means I'm going to go down, start at my terminal side, and I'm going to go down 15 degrees. Right, so I can think of this as negative 15 degrees, or I can think of it as negative pi over 12 radians. Okay guys, that's it. I will see you next time.